talking about our ocean is really important because we all rely on it. It plays an incredible role in our everyday life, and we need to think about that more directly.
Hello and welcome to the Ocean Impact Podcast. I'm your host, Tim Silverwood, and our guest on the podcast today is Dr. Vanessa Pirotta, who is a wildlife scientist, a science communicator, and a superstar of STEM. And I absolutely love Vanessa's energy and skills in communicating science. She's been particularly active in recent years, bringing much needed awareness to whales and pioneering new techniques in how we can capture new knowledge about whales in much less invasive ways than we have before. Particularly, we talk in this episode about using drones to capture whale snot. Yes, you heard it. Whale snot captured by drones in a non-invasive manner in order to help understand these magnificent creatures. But really, the other focus that I really wanted to bring out with Vanessa was her incredible skills in science communication. This is the real nexus, the real intersection, which I and OIO find so important in this day and age. We know problems exist. We know solutions are out there. How do we captivate the attention of the many in order to get this information heard and acted upon? It all comes down to communication. Hey folks, we have wrapped up the Ocean Impact Pitch Fest application period for 2021. This podcast was released on the 29th of September 2021, which means applications are now closed. Thank you for everyone who applied to Pitch Fest and the HP Generation Impact Award. We will be back with the shortlisted finalists from the 12th of October 2021 and the winners announced on the 4th of November. It is going to be huge. The applications are incredibly inspirational and really fill us with this optimism and enthusiasm for rapidly accelerating scalable solutions to transform the health of the ocean. And we couldn't do it without you, our wonderful Ocean Impact podcast community. So thanks as always for tuning in. I hope you enjoyed this episode. Take the ocean out of me. Hello, Vanessa.
Hello, how are you?
I'm doing really well. It's a Wednesday afternoon here in Australia. You're in Sydney, I believe.
Yes, in Sydney. So it's winter time here, and as you can imagine, it's actually transitioning now. I'm so used to saying it's winter, but it's now becoming spring, and there's so many cool things to see out in the ocean. So I'm so excited to have this chat with you today.
Really excited to be having this chat as well, Vanessa. Someone who, we interact with the same communities a lot, but we're yet to have one of these conversations for podcast listeners out there. So very pleased to have you. Why don't we go sort of right back to the beginning, which I often like to do with our podcast guests, and just get a bit of a taste of your origin story in the world of ocean conservation and particularly wildlife conservation. Tell us a little bit about your upbringing, what the ocean sort of meant to you then, what it means to you now, and maybe a bit of a glimpse into some of your work and your career.
Well, great question. So first of all, for your listeners and your viewers, I am focused mainly in the marine science world, and that's where I've done my PhD. But back many, many moons ago, when I was a little girl, I grew up absolutely nowhere near the ocean. And so for those who don't know, who are not from Australia, I grew up on a farm outside of the capital, which is Canberra. And so if you can imagine, very remote area, and it was 3 hours from the closest beach. So I had no ocean anywhere near me. But for some reason, I love the ocean. And I'm sure many of your viewers right now are going, yeah, we love the ocean. And that's why they're there, and here rather. So it's always been this fascination for me, and seeing and learning about it. And so when I did get to go to the ocean when I was younger, I remember catching my first fish with my brother and learning about what it was like to be close to fish and holding a fish in my hand. I must point out that the fish that I did catch was a brim and a flathead, and I didn't know what species they were back in the day. So as a marine scientist now and a wildlife scientist, things have come a long way. But it was like many of your viewers, the ocean was something I always wanted to be part of. And so the journey getting there was one in which took a bit of here and there. So obviously the geographical location of where I was located meant that anytime I'd be near the sea would be on holidays or school excursions. So it wasn't something that was quite immediate for me. So I had to really work towards working out if I was really passionate about the ocean, and that I was. My year 2 teacher said I was drawing dolphins in class and told my mum that. That's pretty cool. And ever since I was a little girl, I always wanted to work with whales and dolphins. And I think it was probably, and I'm showing my age here, it was probably the show Free Willy, so the movie Free Willy, where a
Yep.
young boy, works with a killer whale, and then killer whales were the coolest things on earth. And then I sort of went into the marine science world, and they're pretty cool, but there's more important animals, in my opinion, in some areas that we probably need to focus our conservation efforts on. So I will go into that a little later. So essentially, growing up in Canberra, I went to university. I mind you, for those people who might be studying right now, or year 11 and 12 students who have no idea of what they want to do, but maybe they want to do something with the ocean. Well, I wasn't able to go and do a full marine science degree in Canberra, as you can imagine. So I was fortunate to go to the Australian National University, where I did a wide variety of subjects, but focused on science. So I did a Bachelor of Science and then focused on zoology, evolution, and ecology. So I guess the purpose for that, telling your listeners this, is it doesn't necessarily mean that you have to do one thing. You can acquire a wide range of transferable skills in the science world. And from there, I went on and actually worked at the zoo at the same time. So I was working as a zookeeper and doing wildlife tours as well. So it's kind of a quirky background as to how I became really established in the whale or the marine world. So there was no water near anywhere of what I was doing. But I remember my very first whale watching trip. It was a dedicated trip, which was great, and it was off Eden. And some of your viewers are going to hate me for this, but the very first trip I went out off Eden in New South Wales in Australia. So Sydney's here; it's a little lower down the coast for your international viewers. And the very first trip I actually saw killer whales, which was completely lucky. Now, if you're living overseas and you're in Canada or America, they're probably like, oh yeah, we see them all the time. Well, for Australians, we don't often see them in certain parts of Australia. So that was kind of an amazing thing to see. And there was also humpback whales feeding, which I didn't realize the significance of that back then. I was just this undergraduate university student working at a zoo in Canberra, completely removed from the ocean. So it was a great opportunity to take and we'll talk about it very soon, I imagine, with the whale feeding. But it's a great way to reflect back on where I come from. And then post that, I was able to work in a marine facility where I did have the opportunity to work with dolphins and sea lions, as well as rehabilitating wildlife such as turtles, which was really, really rewarding. I also was able to do a lot of scientific work there with the vet, which is great. There was penguins as well. Australia has a little penguin, which are, if you can see, maybe a 30-centimeter school ruler in height. They're very tiny. In fact, they're the world's smallest penguin. And then from there, I went on to do a master's of research, which looked at trying to prevent whale entanglement in fishing gear. So that was using acoustic devices, which are little sound devices that we can place on fishing gear nets and other types of gear, shark nets as well, to acoustically alert whales to fishing gear presence. And
Are
unfortunately,
they effective?
well, that's a great question. My research only trialed them in a single gear type scenario. So that was in a lobster or crab pot scenario in the middle of the humpback whale highway, which is a stretch of water along the east coast of Australia that we refer to as the humpback whale highway. And I tested when the alarm was on and off. And when I was collecting this information, I didn't know if the alarm was on or off, so I didn't bias the results. And unfortunately, in that scenario, they weren't effective. But that is really important to know that, because these devices are placed on gear in other parts of the world and other parts of Australia. So that's a finding in itself. And then from there, I went on to do my whole PhD, which we can discuss a little bit further.
Fantastic. Yeah, so many different tangents we could take there, particularly on the technology piece to mitigate and minimise bycatch or entanglements, we've had many innovations that have come through ocean impact organisations, programs that are targeting that same problem and challenge area. But yeah, maybe let's go back a little bit more on whales. So whales captivated your attention amongst your absolute passion and love for so many wild creatures. What is it about whales that got so under your skin? And maybe this could be a little segue into just talking about why they are so fundamentally important to the ocean ecosystems.
That's a great question. Well, like many people, and I'm probably biased. I mean, come on, I did my pretty much my entire thesis on whales. But whales they're large, they're big, they breathe air like us. They're part of the ocean, and when we see them, it's often in a distance. And if you're lucky enough to get close up to them, when you do, oh my gosh, it's amazing. I can remember being in the water with a whale many times, and just simply you have to physically turn your body from one side to the other to see just how big these animals are. And as a result, we're very fortunate in Sydney. And remember, we are based here in Sydney for where we're coming to you from. Sydney has the opportunity to see humpback whales in particular come past the coast every year. So they're present, and it's an opportunity to study these animals. And part of my work has really worked on trying to uncover and interpret just how important whales are for our marine environment. So these animals are important. They will feed in one area and poo in another. And this all works in with the marine ecosystem. And in the science world, interpreting our findings and communicating the science around what we're doing is super important because, after all, much of the work that we're doing really does impact us. And so, whales are a great ecosystem monitor of our ocean health. Changes in whale populations may reflect changes in the marine environment that we might not even be aware of yet. So, they're a great study species for looking at the overall health of the ocean.
So when it came time to looking at new ways of understanding whales, and in particular humpbacks, how did you find your PhD subject? Where was a gap or new technologies? What led you to the research? And maybe you can tell us a little bit about that research.
Great question. So, the work that I do is primarily focused on conservation. So, that was my first and foremost thing that I wanted to focus on. And it just so happened that I did my master's on entanglement. So, that's a known threat to whales worldwide, which is a terrible thing and something that we need to work quite hard to mitigate. And so I guess that the combination of wanting to protect these animals, wanting to work with key people in order to do so, so trying to manage some of the threats, remembering that whales unfortunately face a number of natural threats and human-made threats. So there's a number of things these animals will deal with. But the use of technology was something that was really apparent at the start of my PhD back in 2015. So it's going back a few years now, remembering that PhDs don't happen overnight. This takes many, many years. And if you're a scientist and if you've actually done a PhD, people will be nodding. Or if you're an undergraduate student, don't worry, you'll get there. And if you're doing your master's, you will get there. So it was a natural progression. I was working with people working in the innovation area. I was working with people working on drones specifically. I went to an international science conference, the Marine Mammal Science Conference in San Francisco at the time, and I was seeing, drones come up in discussion, but people weren't actually using them the ways that we were ended up using them, which is really interesting. They were starting to, but not completely the way that we work towards. So this was an exciting space and an opportunity to be had. Now, I never pretend to be a drone expert, but what I am is a scientist who will collaborate with people who has expertise in other areas. And that's when you do become a PhD, you really are trained to work out how to problem solve and to get around ideas by collaborating and working with people who will help move the project further. And so that's a really key point. And thankfully, I was able to work with Heligai Scientific, which is my mate Alastair Smith, and he's a fantastic drone pilot. He flies for many famous movies and documentaries you see. And so we were on a boat, and I remember we were doing some drone work. And in Australia, to do what we do, you need scientific license and animal ethics to fly around to fly around whales rather. And I'm sure there's regulations in place in other parts of the world, but the work that we do requires our drones to be really close to whales. So essentially, the use of drones was a tool to enable us to collect information from whales without having to hurt them. So that's the main crux of the question that I'm answering. Because in the past, to collect health information from whales, well, people would hunt whales, which is just unethical and inhumane. And so that doesn't happen. Well, unfortunately, in some places it does happen, and fortunately in many places it doesn't happen anymore. So that's a step forward. But now through my work, we're able to show that we can use these new technologies to acquire these information, biological information, in ways, as I said before, without having to hurt the animal. And so the natural progression to collecting biological samples from a whale were limiting with what you could do using a drone. So you could collect whale poo somehow, and that's a great way of learning more about what whales are eating. But unfortunately, whales don't often poo when you want them to poo. And in Australia, we're seeing a lot of whales migrating, so they're not often feeding, they're relying on this energy budget to do what they have to do. And so that was sort of out. But the other thing was, I just kept, you see whales and there's that breath, that spray that you see, which is the lung bacteria. In fact, that breath that you see is not just water, because obviously they take a breath and there's some water on top of their nose. But when they breathe, it's a biological mixture of health information that we can collect from them. And that contains bacteria, DNA, hormones, you name it. And so that was a really good option as a scientist to go down that path for collecting information with a drone about them. And it was really something, especially at that marine mammal conference many years ago. Can we collect blow from whales to learn more about them? There was an umming and an ahhing at that time. And thankfully, through our work, we've been able to show that, which is really positive. And I also just will add to that last question. The gold standard of collecting health information from an animal would be a blood collection, but an animal the size of a bus is not really going to allow you to present its flipper to then acquire that information. So we couldn't go down that route.
Great stuff. Well, when this becomes a podcast, we'll definitely be sharing links to watch the capture of the whale snot using the drone. But so tell us a little bit about the trial and error involved. Obviously, you saw the academic community merging towards drones, knowing there was this technological innovation. How did that then translate to your work with Heligai Scientific to actually adapt a device that would do the job for you?
Well, that's a great question. And I must point out really early work by April et al., published in 2010, I believe. We're using remotely operated helicopters. So that, they're really old school. Well, they're not so old school, but compared to today's drones, they are very different. So that was sort of like the early stages. And what
They'd be
we were
quite
able
noisy, I'm imagining, were they? Big and
yes.
a bit dangerous around so close to whales.
Yes, so they were noisy, but back then we didn't have the kind of drones that many of the listeners are
Of
using
course.
now that they can pay money for, and it comes in a beautiful package ready to go. In fact, there's devices on there to make sure that you don't crash into anything. Some of the problems that we had at the start was, well, funding. So in the scientific world, if you have money, you're able to do a few things, and that's a positive. And we've seen that with the COVID environment, where the world has dedicated a huge amount of research looking into vaccine production. And that's a really good example of it. With marine science and as a PhD student, you really have a limited budget. So it requires you to make use of what funds you do have. And thankfully, working with Alistair, he was able to essentially bring to life what I had planned. So we weren't able to spend $10,000 on off-the-shelf drones at that time. And remember, I'm working a few years ago, back when we first started. Drones back then were easily $10,000 or more. And the type of technology that you can get now is relatively a lot cheaper. So you could probably get the same technology for around 1 to maybe 2 or 3K thousand. I'm talking Australian dollars here. So if you're in America, that'd probably be maybe $20. Our conversion rate's terrible. And so we had to be quite clever. So we knew we wanted to build something. So Alistair was great because Alistair was able to construct drones. So I wasn't able to buy an off-the-shelf product where it was expensive, and I point out, not waterproof. Because if you're wanting to fly something over a whale, over the ocean, maybe 200 meters or more away from your boat, you also want it to deliberately fly through something that's going to get wet to collect sample. There's not an off-the-shelf product that will do that. Also, I'm sure many of your listeners, because we're all pretty much ocean people here. Maybe some of you have been roped in. Welcome to the ocean world. But flying a drone from a boat is challenging because once you take off, you may have moved and the whales aren't staying in one position. So when the drone goes, oh, I'm running out of battery, I'm going to go home, it will fly completely the wrong way and you're not there anymore. In fact, some people, to get around this, were starting their drones on land and then taking them offshore and just keep replacing the battery life so the drones would not turn off. So as you can imagine, there is a lot of challenges. So we were trying to work out, okay, what kind of drone are we going to do? Because remember, there's fixed wing drones where you have like an aircraft wing and you can launch them, but that wouldn't work well on a boat, especially when you need to kind of have a runway. Or there's your propeller-driven drones, which are like the quadcopters you see now. I'm not going to name any brand names. I'm not sponsored by any of them. But the drone we came up with was a quadcopter, so 4 propellers, and it had really sophisticated technology for the time. Now, mind you, our technology is so much more advanced, which is cool. And there's now all the electrical instruments which are now housed in the plastic part, which is the body. So it has 4 propellers, a main body which houses the electrical gear, and then on top of that we had a mount, and we've got photos of this I can show you. I've also done a TEDx talk which you can see the drone, how it looks like, and we've got a little GoPro on top so we could see what the drone is seeing, but also we had a FPV, or first person view camera, as well at the bottom. So we had 2 cameras, one to check that we were sampling whale snot and how well we're sampling it, and another one so it could assist us to see the whales. But also at the same time, my role on the boat was to make sure that the drone pilot, Alistair, was doing an amazing job of what he does, but making sure he doesn't necessarily get sick, because getting seasick at sea, being without a drone is one thing, but looking down and holding a drone while you're flying out to a whale can also be another thing. So he was incredibly skilled at doing that. But before we got onto the ocean, one of the trials that we had to do was work out where are we going to collect the whale snot sample. And one of those things was, okay, where do we place it? Do we place the Petri dish? So we used a Petri dish for your listeners. This is a plastic device. It's very non-technical. It's just a plastic dish with a lid, and that's where we collect our snot sample. Remembering, if you just joined us, we want to collect whale snot for an assessment of whale health. So we're focusing on collecting bacterial DNA and viruses via this method. And at the time, we hadn't proved that we could do this. So it was really important that we tried. And so we kind of thought, okay, let's see if we can put the Petri dish on top or the bottom. And so one of the ways that we tested this is we used sprinklers and we used visual aids to do this. And we found that by placing the Petri dish underneath the drone, the propellers would push the sample away. So the sample would then come down and then you'd lose the sample. So that wasn't good. So by locating the Petri dish on top of the dish, or of the drone, we were able to ensure that when the drone would fly through the sample, it would collect that sample, but also the propellers wouldn't be pushing the sample away. So there are a number of errors. And also the first time we went out to sea, we went on a small vessel, which meant that the drone did not want to take off because it had to have some level of stabilization. And the other thing was, so we moved to another vessel. And then the other thing was making sure that we worked out which whale we were going to target. So your listeners might think, well, how do you know the difference between each humpback whale? They do look quite similar, but when you look at the defining features like the shape of the dorsal fin, the color pattern, they are quite different. So the whales in which we targeted we tried to target as many whales for sample collection, but obviously this would be dictated by when and where each whale would come up and take a breath.
Wow. Okay. So you figured out all the technical challenges. You've gone out there and started doing your sampling. Take us to what the results show. What have you been able to understand about the target whales through your research?
Well, that's a great question. And I must point out that for your listeners that don't really know the concept of how we collect the sample, so it's literally the drone is launched from the boat, flies out to the whale's position, the whale takes a breath, the drone goes through the sample, collects the sample, and it comes back to us on the boat. Once I collect the samples, I will then go back to the laboratory and then process them. Kind of like getting your COVID swab. And again, I'm sorry to bring COVID into it, but everyone's been swabbed these days. The findings of this work Okay, so what did we find? Why did we invest so much time, energy, animal ethics, scientific licenses, part of a PhD? Why? Why did we want to do this? This is a really good question, because we don't just go out and do science because it looks good or it would make for a great story. There was a massive reason behind this. And one of the things was showing, does our technology, can we access whales in this way? Can we collect bacterial information from their lungs to show that this method is applicable? And tick, we can, because what we were able to do was to collect bacterial DNA from these whales to provide a snapshot of whale health. So the second thing we did was create a baseline of information on the types of bacteria living in whale lungs. Now, we sampled over 70 whales or so the pool wasn't very big at that stage. But what it was doing was showing us that we're able to collect genetic diversity and knowledge about what we would consider relatively healthy whales. So to compare collecting samples from a whale that's free swimming, migrating from Antarctica, that's the best kind of sample you can get. And then we can compare that to animals that unfortunately may have stranded, and we can look at their whale snot to see how much that differs. But also, what we were able to do was describe a whole number of different types of bacteria living in their lungs, which we were then able to compare to whale snot lungs in other parts of the world, in which we found some overlap, which is super cool. The other cool thing we were able to find, in addition to proving that this method works and it's reliable, we were also the first in the world to collect viruses from whales using a drone. That's really cool, because this is Aussie innovation right here. And we're able to prove that we're able to collect viruses via this method, which was really, really challenging. And it did require samples to go through a variety of different methods in comparison to the bacterial DNA. So that's another thing. And from that, we were able to link, and this is what's really cool, working with epidemiologists, which, as you're all very familiar with, you probably see them on TV often. Viruses need a host, and whales are mammals like us, so they're able to be big incubators for having a lot of things in their lungs. So that's what's really cool. And in addition to that, one of the viruses in particular that really stuck out to me was a virus that was associated with the McMurdo ice shelf in Antarctica. So some of your listeners might be going, okay, why is that so significant? Essentially, what we've done with this work is we've collected the smallest organisms from one of the biggest animals on Earth. And this is telling us that these animals are going down to these environments that are subject to climate change and in areas that we can't always get to. I mean, I've been to Antarctica, it's an amazing place, but it takes a long time to get down there. I wasn't privileged to fly down, so I had to go via ship. And I also went from Tasmania down to Antarctica, so it was a long trip. So we can essentially use these animals as monitors of ocean health in some capacity, because if we can start detecting certain types of bacteria or viruses which thrive in certain temperatures or environments, this may be indicative of changes or subtle changes going on in our marine environment. And that's super cool. I will also point out that as a result of this technology use, we were also able to then have Alistair collect dolphin snot, which is another world first, via a drone. So it's going from one species to another, and working on humpback whales is a great study species because there's lots of them. But then we've proven that it works with them. We can then adapt this to looking at other species in more need of conservation, can help in Australian waters at least, like the southern right whale, where their numbers haven't really rebounded post-whaling.
Oh, congratulations on those wonderful outcomes and achievements. And I'm sure, like you've identified, this is really just the beginning. We're talking about a 6-year journey in developing this technology and seeing obviously the price come down, the technological capability increase. I also wanted to sort of maybe use this as a way of saying, exploring, where else are you seeing technology or innovations in drones and unmanned vehicles in order to help do science and to help understand natural processes?
Well, one of the examples is obviously in the ocean. So we're also measuring body condition of whales. So to see how big and how much they've put on or how much they're declining in body condition. Another really cool example on land is assessing animal populations. So looking at penguin colonies, seal presence in different areas, flying drones, and using the mapping tools on the drones to stitch together images. So this would be a drone, you send a drone out and it takes photos, photo, and then it clips all the images together, where then the scientists can then work out how many animals there are in a certain area and do surveys without having to disturb these animals. And I will also point out there's been a number of studies in place to make sure that drones in certain environments don't impact on animals, or maybe they do have an impact. So a great study was done here in Australia looking at the acoustics of a drone flown over the water, which is a really good thing because we need to make sure that animals like whales and dolphins are not disturbed by the drone presence. And fortunately, in our work, we found that the animals either knew the drone was there and did absolutely nothing, or had no idea that the drone was there at all. But this is all really timely, especially for the Pitch Fest, where you've got a lot of people thinking about technology and innovation. And yes, we've talked about drones in the air, but underwater drones are a great example in the ocean, collecting oceanographic data. We've also got drones looking at water quality, ocean air temperatures, huge number of applications. And that's what's so exciting. And that's what's so great about innovation and technology coming together to conserve. And that's what I'm all about, wildlife conservation. And that's what the technology component of my work has led me down to go on these exciting little journeys.
What I found really interesting in the last few years is, of course, the advancements that have really enabled fantastic science, but just the community adoption of drones has been a really interesting journey for me as a surfer and for many of my surfing brothers and sisters out there, because now what was previously out of sight, out of mind, but perhaps quite close to us, is becoming much more obvious, and it's been revealed. And so, I'm just thinking about, in the eastern suburbs of Sydney, Drone Shark app, and how they're
Yes.
identifying a lot more, close calls with various shark species, identifying grey nurse shark populations that perhaps weren't really as well understood, and leading so many people. I'm seeing this on social media from all around the world, these clips emerging of these close encounters, but not in a high risk situation whatsoever. So it's actually helping surfers and ocean swimmers and other ocean users to really understand so much more about the ecosystem that they are actually playing in at any one time. So, and that might be a little segue into, footage that you've obviously studied around certain feeding behaviours and of humpback whales in southern New South Wales.
Yes, that's right. And you're absolutely right. The use of drones is allowing us to understand the environment better, but also for the idea of sharks, there are so many cases of people swimming with sharks every day and nothing happens, which is, we need to see that. I think there needs to be some advocacy for that, because we really need to have that awareness. And I'm sure many of the ocean goers know that when they hop in the water, they share it with these animals that are part of the ecosystem. But more specifically, the feeding component and what drones are being able to reveal. For those who don't know, we last year off Australia, specifically south of Sydney. So again, if you're not from this part of the world, south of Sydney, you kind of go down maybe 5 hours or so. There's an area down there known as Montague, and there's Bermagui, where there's Montague Island. There's also Eden, Maroonbula, Bermagui, as I said. And this is a great spot. This is such a beautiful, the New South Wales south coast is gorgeous. And I can imagine there's maybe probably a lot of people going, yeah, we know, don't tell too many people. But fortunately, last year, for the very first time, a massive event happened. And it was a mass supergroup feeding event of humpback whales feeding in one area. Now, this was documented by the use of drones. So Brett Dixon, nod to you, who was able to capture some fantastic footage for us, but also via ecotourism companies as well. So there's Sapphire Coastal Adventures is a great example. And what they were doing essentially was out there, they were collecting information, they were whale watching, and together, all these ecotourism companies were able to document this feeding event. So a super group feeding event is where there's 20 or more humpback whales within one area, within 5 body lengths of each other. So there has to be more than 20 and in close proximity. The only other place that this was ever discovered, and hence the definition, was by it was in South Africa, and this is now seen on a regular occurrence. So they see big groups of whales feeding there quite often. We saw it for the first time last year. It was pretty epic. You have this drone vision of just the whole screen, whales coming up here, there, and feeding, turning on their side. That was super cool. So I knew there was something going on that was really interesting. So fortunately, I was able to collaborate with other scientists. And Kylie Owen, Dr. Kylie Owen is great. She's did her whole PhD on, or majority of it on whale feeding in that area, which is great. So naturally, I worked with her. And we also were able to, with the team, interpret what we were able to see. So this had Maddie Brazier, Professor Rob Harcourt, also Dave Donnelly from Killer Whales Australia. So we all came together to produce a story on what was going on. But it also turned out that these whales weren't just feeding in big groups. They were using some were using bubble net feeding behaviours, which has never been observed in Australia ever before. So not only did we have an Australian first, which was the supergroup feeding event, but the use of bubble net feeding behaviour observed in Australia. So for those that don't know what bubble net feeding is, it's where a humpback whale will take a big breath, then they'll go down and they'll deliberately blow bubbles from their nostril, which is on top of their head. So their nostrils, their two nostrils. And then once they create a bubble around their prey, which might be krill or fish, they'll ball it up really, really tightly, compacting it, that's the idea. You're creating a net. Then when the time's right, they can do this independently or with cooperatively with other whales. They'll come from underneath or on the side. They'll expand their throat pleats really big, really, really wide. I'm talking, think a slinky or an accordion. You know how they open up massively, and then they'll engulf their prey. So they'll engulf their food and the water. Now they have no teeth because they're baleen whales. So they use the hair-like structures hanging from the roof of their mouths, which is known as baleen. And then what they'll do is they'll bring their tongue to the roof of their mouth and expel that water and then swallow their food. That's bubble net feeding 101.
Amazing. Look, so I guess what do we know then? Obviously, it's been documented now. I think I saw that maybe it's occurred again in recent weeks.
Yes, that's right. So our first publication came out this year. So Pirotta et al., and that's on. You can Google it. First ever evidence of supergroup feeding behaviour and bubble net usage in Australian waters. That's not exactly the title. It's quite a long one. So that it's available to check out. And so, yes, this year it was also seen for the second year in a row, which was the big question, because in science, often you ask a question and then it answers or never answers, and then more questions arise. So we saw it again. And by we, I wasn't physically there, unfortunately, but Sapphire Coastal Adventures were able to document this again, which is really cool. And the vision from Davey Rogers on the drone was amazing. And it happened again. So will we see it again this year, or will we just have to wait to see it next year? Maybe. I will also point out that Tasmania also saw the use of bubble net feeding down that way. So Tasmania, think of Australia, then we've got that other little island down below. That's Tasmania. And Tasmania were able to document the bubble net feeding, but not the supergroup feeding events. There was also other evidence of feeding in other areas like Victoria as well.
So at what point does this revelation, this revealing of this behaviour meet the increased use of technology and increased activity in monitoring the ocean, bringing what was out of sight now in sight, versus understanding that there could be changes that are taking place as a result of other factors, population increases, climate change, moving currents, food sources? How do you tackle those challenges?
Good question. Well, thanks to technology and it being accessible like drones and social media. So this is happening here, guys. Come and see this. We're able to, and as a scientist, I'm able to engage with these people to create a scientific story. So this goes beyond just posting an Instagram reel or a story saying this happened. It is really talking about transferring this into scientific knowledge and communicating this to the scientific community around the world. And so that's what I made sure that I did with the first publication. So that's tick. But it really opens up other questions. So are we seeing changes in the environment which leads to the opportunity for so many whales to feed? down in the southern waters that we're seeing here, which are not even Antarctica. We're still in Australia, where it's warm up here compared to Antarctica. Are we seeing changes that are happening that we would not have necessarily detected, but thanks to the use of drones and people telling us what's going on, we're able to see this? Is it the rebounding humpback whale population that is a result of stopping killing whales, first of all, which is a good thing, but also Australia's protection for these animals? But also, is the ocean becoming really warm, which is, well, we know climate change is happening. There is scientific evidence to support that, which means that in the ocean environment, the changes that are happening as a result of climate change might be happening in ways in which we're unable to detect it just yet. Or are these changes happening in a way that we're harnessing technology and the animals' behaviors to learn more? And then I would imagine that the next step is, how can we implement new technologies to acquire more information from this happening? So it's a really dynamic, changing space that we're working in. And even the example of the bubble net feeding, how did that arise? We know that some whales in Antarctica use bubble net feeding, but did it arise as a result of the humpback whale population rebounding quite well? And we now see behaviours emerge that were occurring pre-whaling. Are we seeing other whale populations, other members from different populations in the southern hemisphere come over, which typically we don't see too much mixing happening, but maybe some of those whales who know how to bubble net feed are coming over and saying, you know what, this is how we do it. This is I'm going to show you how we do it. And they're teaching each other through cultural transmission. There's just so many questions, which is exciting.
And what I'd love to sort of focus on there is sort of just back to, the sign of our times and more citizens engaged in monitoring, and you then being able to turn that into a bona fide scientific structure. But specifically your unique skills in engaging as a science communicator and being picked up and interviewed by media across the world, it just gives you, of course, an opportunity to share that foundation of just how important this is and how we can use this to greatly improve science and understanding. But tell me about that. Like, have you become a great science communicator because you recognized how deficient it has been in the past and it was important, or is this just a natural quality of yours? I get the impression it might be a little bit of both.
Well, I started working in a zoo, and we often would tell people what's going on. So there's obviously a bit of, talking experience that I've had in the past. But when I started my PhD and my master's, you'd do this scientific work, you'd be away, you do these things, and then you appear when something's happened. And there'd be people that wanted to know more about that. And so it was at that time where I was like, oh, these people want to know. And then I'd be approached by the media to talk about this. And I recall one time going, oh, I should just ask my supervisor if I can talk about this. I don't know if I'm the person to do so. And I was actually a legitimate science student doing post-grad study and working on these animals. And I think probably back then, well, I was more than qualified to talk. And then to see the news go and approach someone who has absolutely no scientific background to talk about this, well, I was kind of like, okay, I probably should as a scientist. It is an obligation to share work and also to communicate the work that you do. Also noting that many research projects are funded by the public, government funds. So we have an obligation to know where our research dollar is going. So it came out of a result of people wanting to know about research, but people wanting to understand this in ways that was accessible. In addition to that, people also wanted legitimacy. So they wanted to know that the person telling them this information was an actual scientist and someone working in the space and publishing. So that really helped, especially when I'm approached by really big areas and news networks that they interview amazing Nobel Peace Prize winners, things like that. So to be able to be on that platform and explain the science, really, I would feel now a big part of my work. And also being there for the next generation, letting young minds see that science is accessible and science is fun, and science can be communicated in ways that encourages us to learn more and ask more questions. And in the world of the ocean, it's really important, my work in particular, for highlighting the fact that we have such a beautiful world, but also getting to those people who wouldn't necessarily care about the ocean. So by highlighting it in ways that's colorful, interesting, and appealing, that's hopefully going to draw in some people to think about their actions on land, which have implications for our marine animals in the ocean.
Yeah, and you really are to be commended for the work that you're doing and the precedent I think you set as a really impeccable science communicator. So, how does that then
Thank you.
translate to you in terms of, you just mentioned, helping the next generation and the current generation access the STEM subject areas, feel inspired and confident that this is a career and an exciting path? Hey, they might even be able to be uh, the influencer or that influential voice that they thought they want to be in another realm, but do it through such a meaningful output as science.
Yeah, that's the thing. I must point out this goes beyond just posting an image of yourself on a beach or something like that. That's all well and good, but if you are doing it with a real purpose for, and you're an actual scientist doing these things, this has a huge momentum for the younger generation to see this. And so it is an opportunity for young minds to go, wow, that's a job I might like to take. Or the thing I will point out is I like to also be really honest about the path getting here. So remember, for those
Mm.
who hadn't joined us at the start, I was nowhere near the beach. When I started working in a marine facility near the ocean, I didn't even know there were two tides a day, a high tide and a low tide, and it would happen often. Like, oh no, we can't do that. There's a high tide or a low tide. I didn't even know that that was a thing. So, and then my journey went through this way and then this way. So my journey in the STEM world, so science, technology, engineering, and maths, meant that you can acquire a job doing something specific, but then take those skills to doing something else. So if you're wanting to maybe work on a specific oyster, the path getting there might not be that direct path. You might do other things to get there. If you want to work on creating digital content to help support an NGO to promote their work, they need you. We all need all these variety of skill sets to come together to work for a greater good. And so the way getting there might not necessarily be straightforward, but if you can acquire skills that allow you to use those transferably, then that you're going to set yourself up for a very exciting career, and a career path that doesn't necessarily, it will surprise you on where it will go. And for my work working in the marine world, I'm now also working in the terrestrial world, looking at applying some of those skill sets that I have in the ocean into the technology space on land, looking at illegal wildlife trafficking. So as you can see, don't just limit yourself, don't just pigeonhole yourself to one area. There's a whole variety of things you can acquire, and the ways of the paths getting there is a little bit different for many people. And you do have to sometimes do the hard yards. I won't pretend that getting to do what I've done is super easy. You really do a lot of work. It is incredibly difficult, especially during a PhD, and other PhDs would be going, yep, I know. Making sure that my samples didn't go off in the fridge, making sure that the weather was right, making sure that I was able to have my work, do all this amazing work, and making sure to be published, and then submitted to people to then criticize it and go, you could make some changes here, or this research is not that good. So there's a whole thing, there's a whole variety of things that one needs to think about. But what's really exciting is that the future of science and technology and innovation is exciting, and a lot of the jobs that will be existing in the future aren't even apparent yet. They're not even there. The jobs of tomorrow in STEM fields haven't even been thought of yet. So that's why we really need to invest in people and that next generation in science to make that difference. And that's what hopefully my work will do, by motivating people about that. And especially in the marine world, using whales as an example of getting people to care is hopefully one in which, teamed with science and technology through the use of my drone work, will enable us to go forward with spreading that message and go forward to allow that next generation, whether you're primary, secondary, in university, haven't started university yet, an older student maybe wanting to go into studying again, wherever you are, don't be afraid. Follow your passion. If you're following something that you're passionate about, it will be much more easier to pursue those difficult times.
Such great words of wisdom there, Vanessa. And I can certainly see why you are a superstar of STEM and such a strong and reasoned voice for everyone, but particularly young people to get involved with STEM. So I think we can pretty much move towards wrapping up the conversation today. Is there some subjects that you'd wanted to touch on today that you haven't had the chance to yet, or any questions you'd like to ask?
Well, I just think that it's Ocean Impact is such a great organization for really highlighting the roles that we all play in the ocean. So if you want to be part of the ocean, whether you're working in a local community, whether you're a scientist, you don't have to necessarily be these things to make a difference. You can just make a difference by being you, by listening to this and having a conversation at dinner, maybe breakfast, or maybe you're going for a run right now and you're listening to this. Thinking about our ocean is really important because we all rely on it. It is plays an incredible role in our everyday life, and we need to think about that and more directly. Whether you're eating a lovely fish meal, sustainably caught, hopefully, you really need to think about your actions on land and how you generate momentum around the ocean. So it's all about thinking and being conscious about our actions, but also enjoying it. Make sure that you enjoy the sea and think about it often when you're in times like right now when many people might be disconnected from it.
Love it. Been a pleasure talking to you today, Vanessa, and we look forward to working with you and following your work over the years to come.
Thank you so much and happy listening, everybody. Thank you.
We'll share plenty of links in the podcast description to where you can find out more and follow Vanessa's work. Thanks again.
Thank you.